Good morning, students. Let's wait for 2 more minutes to join the others. Okay, so we'll start. And today's topic is unsupervised learning. So what is unsupervised learning? So unsupervised learning is a uh, branch of machine learning focused on analyzing and modeling data without the use of labeled responses. Okay, yesterday we have learned about supervised learning, right? So that was based on labeled datasets, but here we don't need labeled dataset. We can apply unsupervised learning in unlabeled datasets. Okay, so this approach is crucial for uncovering hidden patterns and structures within the data and making it vital for various applications such as clustering, anomaly detection, and recommendation systems. Fine. So let's see what is unsupervised learning. In the definition, unsupervised learning is a powerful machine learning technique aimed at discovering hidden patterns or underlying structures within input data that lacks explicit labels. Okay, enabling the algorithm to identify relationship and groupings naturally. So it is printed twice. Fine. So what is the difference between unsupervised and supervised learning? Anyone can tell me? Okay, so basically the difference is the supervised learning techniques are worked on labeled dataset, and unsupervised learning algorithms are worked on unlabeled dataset. Okay, so there are some real world applications. Unsupervised learning is frequently applied in various fields such as market segmentation for targeted advertisings and anomaly detection in fraud prevention and efficiently organizing extensive datasets and empowering businesses to derive valuable insights without relying on predefined levels. Okay, we'll see what is, we'll see the datasets, how it's look like. Okay, so there are three types of unsupervised learning. The types are clustering, dimensionality reduction, and association rule learning. Okay, so what is clustering? Clustering groups similar data points together. Okay, helping to identify patterns. An example is customer segmentation in marketing. We'll see this clustering broadly in the next slides. And what is dimensionality reduction? If you remember in our studies session, there are multiple features, right? There are 4 or 5 features for each row or each instance. So that are called dimension. Okay, there are 3 or 5 dimensions. Fine. So here it is saying that this technique reduces the number of variables, simplifying data without losing essential information. PCA, this is one algorithm to execute dimensionality reduction. Okay. Then we have association rule learning. This identifies interesting relations between variables such as market basket analysis. We'll see this also in next slides. Fine. So here is clustering. So clustering is a powerful technique for grouping similar data points. Used in various fields such as marketing and bioinformatics and geographic data analysis. Fine. So these three are techniques to perform clustering. The most widely used technique is k-means clustering. This algorithm partitions data into k distinct clusters. Okay, here k means number of clusters. So anyone can tell me what is a cluster in a simple term, in a simple meaning? What is a cluster?
The group of similar objects.
Yeah. So yes, fine. So there are clusters in our society, right? Like in our jurisdiction, there are some clusters are there to maintain some geographical boundaries are there, right? So that is cluster. So clusters are two types. One is like simple clustering and one is hierarchical clustering. So here it widely used in customer segmentation. Fine, we'll see it. And another one is hierarchical clustering. This method creates a tree of clusters. Fine. This will create some linear clusters and this will create some tree-like tree of clusters. Okay. Allowing for multi-level representation of data. It often used in bioinformatics to classify genes or species. Okay. And we have DBSCAN, that is density-based clustering algorithm. Fine. DBSCAN means density-based clustering algorithm. So it is mainly grouping data through the density. Okay. What it's saying that group together points that are closely packed together and marks points in low density. Wait for a minute. Low density region as outliers. Okay. We have already discussed what is outlier. I've told in the yesterday's class. Anyone remember? Okay, we'll see it. It's effective in geographic data analysis. Fine. So next we have k-means clustering. So k-means clustering is an unsupervised learning algorithm used to partition data into k distinct clusters based on feature similarities. Okay. It okay. It iteratively assigns data points to the nearest centroid. Okay, we'll see what is centroid and updates centroids until coverages. Okay, this technique is often a precursors to dimensionality reduction and helping to simplify complex datasets. Okay, let's see what are the steps of k-means algorithm. So the k-means clustering algorithm involves several key steps. First one is determine the number of clusters. First, see how it looks like, how clusters looks like. Okay. So this is a picture how clusters look like. So here you can see this is cluster 1, this is cluster 2, here's cluster 3, and here's cluster 4. And these big circles inside the clusters are the centroid. Okay. This green, yellow, orange, and black, these are the centroids. Fine. And these small circles are the data points. Okay. So these similar data points are grouped up in a same cluster. Okay. Now, is it understandable?
Yes, sir.
Okay. So first thing is to determine how many clusters should be there for the better clustering of any dataset. Fine. Then we initialize the k centroid randomly. So we have to first decide how many number of clusters should be there. Okay. So there are 4 clusters, right? 1, 2, 3, 4. Fine. So after that, we have to do what? We have to initialize the k centroids randomly. That means there are 4 centroids, right? So k means, here k means 4. There are 4 centroids or 4 clusters. So we have to initialize the centroids. Where should be the centroid located? Okay. Next, we have to assign each data point to the nearest centroid based on distance matrix. So next we have to do what? We have to calculate the distance. Fine. This one green dot, it is inside the second cluster. Fine. Is it possible that it goes to the first cluster? Is it possible that? Because the distance between yellow centroid and this green dot is quite high, right? The distance is quite high, or this distance also is high. So it will go for the green cluster. Fine. So do you know how we can calculate distance of 2 points? Do you know the formula? This is done through Euclidean distance. Okay. Have you heard about that?
Yes, sir.
Okay. So can you tell me the formula?
Sir, root over x2 minus x1 whole square plus y2 minus y1 whole square.
Yes, yes, yes. Okay. So give me a second. Just give me a second, okay? Is it visible now?
Yes, sir.
Okay. So where we are? We have covered till second one, right? Now this is an example data set. Okay. Here we have customer ID, gender, age of the customer, annual income of the customer, and spending score. So what do you think? Which are the important features here? Which are the most important features here? Customer ID is
And
not a very important feature. Yeah, tell me.
spending score and annual income.
Yeah. Absolutely. So these two are the most important features here. Gender is not that important for this analysis, this clustering, and age is also not important. Fine. So we want to uh, make clusters for annual income and spending score. Fine. So the formula for distance is d equals to what? Root over x2 or x1 minus x2, right? Just ignore my handwriting. Okay. X1 minus x2 whole square plus y1 sorry. Yes. So this is the Euclidean distance formula. Fine. So in this data set, if we want to determine the number of clusters, that is k, let's assume that k is equal to here, k is equal to 2. Okay. Let's assume that k is equal to 2. Fine. Then what is the next step? Initialize k centroid randomly. Randomly means we can pick any of this as a centroid. Fine. Any two of them as two centroids. Okay. Let's assume this as first centroid. This is C1. Okay. And let's assume this is a centroid to C2. Fine. So these two are for centroid 1. So we have 15 and 39. We have C1, that is what? 15 and 39. Fine. So this is our centroid 1. Okay. And what will be the centroid 2? That is 15 and 81. Okay. C2 will be. So why we are using two centroids? Anyone? You are not getting? Am I audible?
Yes, sir.
So we are taking two clusters. Fine. Two clusters. So two clusters, each cluster having one centroid. Centroid means center. Fine. Simply in simple terms, centroid means center. So let us assume these clusters as a circle, though it is not a circle, but we consider it as a circle. Fine. So if we consider a circle, so circle has how many centers? It has only one center, right? So each cluster having only one center. We are taking k as 2. That means we want to make two clusters. Fine. So there will be two centroids. So our algorithm is saying that determine the number of clusters first, that is k. We have determined it as 2. Okay. It is, sorry. It is 2. And we have initialized centroid as C1 and C2. Okay. Then assign the data points to the nearest centroid based on distance matrix. So now we have to calculate the distance. Fine. So if we take for C1 centroid, this is X1 and X2. Okay. We are taking this point as, sorry, X1 and Y1. Sorry. X1 and Y1. Okay. This is a simple thing, in a graph, there will be first point is considered as X, second point is considered as Y, right? till here, is there any confusion? No? Okay. So here this is x1. Just a second. This is x1 and here this is y1, right? So we have to calculate what? The distance between any point from here. We have decided 2 points as centroid. Okay. From next, we want to assign them in any one of these clusters. Fine. Any one of these clusters, these data points should be go to the C1 or C2 clusters. Let's draw C1 and C2 clusters. Okay, this is C1 cluster and this is C2 cluster. And what is the centroid? Here is the centroid. Okay, this is the centroid. First centroid location is what? 15, 39. Okay, this is C1, 15, 39. And the second one is what? 15, 81. 1581. Fine. Okay. So the next data point, we consider it as P. This is a point. Let's consider this point 16 and 6, right? So 16, 6. Okay. So 16 will be what? 16 will be x2 and 6 will be what? y2, right? Am I clear till here?
Yes, sir.
Okay, Iman Bora. You have raised your hand, Iman Bora. Fine. So now we have to put this two thing in this formula. So what will be happen? Like what will be the distance? Root over what is x1? X1 is 15. Right. This is simple calculation. 15 minus x2 is 16, right? Here is the x2. Okay, we are doing this. X1 minus x2. This is x1, this is x2. Fine. What will be the answer? 15 minus 16 whole square. And here is y1 minus y2, right? This is y1 and this is y2. Y2 is 6, y1 is 39 minus 6. Calculate this and tell me what will be the answer. What will be the answer for 39 minus 6 whole square?
Sir, 1089.
Yeah. So it will be 1089. So what will be the total? Final answer? 1089 plus 1 root over 1090 will be near to
33.01.
near to 33. Okay. 1090. So fine. We'll take it as 33. Okay. 30. So 33. So we have got the distance for C1, right? We have got the distance for centroid 1. That means the point, if we consider this point is, if we consider the point here, so the distance between these two centroid and this point is what? 33. Okay. Now we have to calculate the distance for centroid 2. Can you calculate it first? Can anyone tell me the answer? Like 15 minus 16 and 81 minus 6. Okay. We'll do it in the programming also. This is same. Eighty-one minus 6. This is 1. And what is the answer for 81 minus 6 whole square?
5625.
565. Okay, thank you. And after that, 5625. Okay. Then, after removing the root, it will be near to 75. Okay. 75. Fine. So that means this distance is 75. Okay. So what do you think? Where should this point, new point, should go? Where should this point go? Which cluster should it belong? Can you tell me? For C1, for first cluster, the distance is 33. That means it is nearer to C1. right? Distance is less than centroid 2. So in our algorithm, let's say in our algorithm, assign each data point to the nearest centroid based on distance matrix. So after our calculation, what we have received, that which one is nearer to this new data point? This one, right? C1, centroid 1. So this data point should go here. Okay. In the centroid 1. Fine. So did you understand this?
Yes, sir.
This calculation and all? Is there any doubt? So see why we are doing this. This is one data set, right? So if you consider something like we want to separate people who have similar annual income and spending score. So these centroids are representing that. These clusters are representing that. These clusters will separate the people who have similar annual income and spending score. Fine. So here the annual income might be same, but the spending score is different. That is the reason why this new data point 6 and 16 and 6 goes for cluster 1. Okay, do you understand? In this manner, we can categorize, we can make segmentation for any like market segmentation we can do. Okay. So after this step, after all points, like we have to, the algorithm will do what? It will calculate for all the points, will calculate the distance and assign all the points to their respective clusters. Fine. Okay. After all points are assigned, like after each step, there is now 2 points. Okay. So now what will be done? Like this cluster centroid will shift somewhat here. Okay. Now this will be the new centroid. So how it will done? It will done it will take the average. It will take the middle point as new centroid. Okay. Every time it will shift like this. Okay. Do you have any question? Sort of. Your mic is on, sort of. Fine. Do you have any doubt till here?
No, sir.
Like after all the points are assigned, update the centroid by calculating the mean of the assigned points. Okay. After assigning all the points to their respective clusters, the mean point will be calculated for each cluster. For each cluster, there will be multiple points, right? Like this. And the, oh, sorry. Like this, there are multiple points in every cluster. And after that, what will happen? We have to calculate the mean point for considering every points, and that will be the centroid for the cluster. Fine. You get this?
Yes, sir.
Okay, so this process of assignment and update is repeated until the centroid no longer changes significantly. Okay, this process is a repetitive process. So until and unless the centroid stops shifting its position, then the clustering process is completed. Okay, this algorithm will stops the process. Okay, fine. Do you have any doubt? No? Everyone got this? Fine. So this is the visual representation of clustering. So you can see these are the original unclustered data. Fine. These are the original data. These are plotted in a graph. Okay. So like x1, x1, y1 thing like that. It is plotted in the graph. And after the clustering, this is one cluster. The orange one is one cluster. The blue one is another cluster. And here's the another cluster that is green. So do you have any doubt like why these 2 points are, or these 2 points are separated by two clusters? Do you have that kind of doubt? Anyone having that kind of doubt?
No, sir.
No. So why these are not included in the same cluster? Can you tell me briefly? Or
Sir,
yeah.
because that point is closer to the centroid of the blue one.
Yes. Very good, very good. So the centroid will be somewhat located here. Fine. For blue, the centroid will be here. And for orange one, centroid will be in like for just a second. For orange, the centroid may be located here. Okay. And for green, centroid may be located here. So the distance from this centroid to this one uh, point is closer, right? Fine. Okay, let's move to the next slide. So we don't have anyone having any other question? Anyone having any doubt? No? Fine. So next we have dimensionality reduction. So there is a technique called principal component analysis that transforms data into a new coordinate system focusing on variance widely used in facial recognition system. Fine. So what is dimensionality reduction? Actually, it is like we are not considering these three features, right? Like gender and age. We are ignoring these two features, and this is actually the customer ID. Okay. So we are not considering these three features. That is dimensionality reduction. Okay, in simple terms, that you can refer these three reduction as dimensionality reduction. Okay, if there are this is a 2D two-dimensional space, right? This is a two-dimensional space. If we consider more points, then it will be going to three-dimensional space, right? If we consider age along with annual income and spending score, then it will be what? A three-dimensional space, right? We have to calculate everything in terms of three-dimensional. So dimensionality reduction does what? It reduces the unwanted or less important features or variables from the dataset. Fine. And t-distributed stochastic neighbor embedding. This is in short form, it is t-SNE. So this is useful for visualizing high dimensional data by reducing it to 2 or 3 dimensions, often used in complex datasets. Fine. In a complex dataset, there might be some like 10, 12 number of features, 10, 12 number of, you can say, columns. Out of them, there will be 2 or 3 most important features. So this technique will do what? This technique will keep only 2 or 3 features for this analysis, and it reduces the complexness of the dataset. Fine. So autoencoder is there. Neural networks, you might not know about neural networks. So neural networks designed to learn efficient data representations applied in image denoising and feature extraction. So this can be, this is a advanced form of this, and you can use this in neural networks. That is a part of deep learning. Fine. So we're not gonna cover this. And here is the third form of unsupervised learning, that is association rule learning. Okay. So what is the term association? What do you mean by association? Anyone? In simple meaning, what is association or associating or associate? It means what? The relationship or the associativity, right? So here market basket analysis is done through what? Association rule mining. We'll see this in our practical session. So this technique uncovers how items are associated with one another. Okay, how items are related with one another. We can say that in a transaction. Okay. For example, if customers who buy bread often buy butter. Okay. If the customer sometimes do what? If he buy bread or if she buy bread, then often she also buys butter along with bread. So this is association, right? This relationship can inform product placements. Okay. So in a supermarket, suppose we are inside a supermarket, so there should be bread and butter closer to each other. Fine. So this is a simple explanation of association. Okay. So why it is important? So that we can find the pattern of buying something. Okay. Or in other aspects also we can use association rule. And there are a priori algorithm is there to find the association rule. Okay. That is how the one item is related to other item. Okay. This is done through what? Previously known data, and a classic algorithm used to mine frequent item sets and derive association rules. Okay, this a priori algorithm does what? It does derive association rule from frequent item sets. Okay, it's beneficial in retail for understanding customer purchasing habits. Okay, so we'll see this in our practical session. And there is another algorithm, that is Eclat algorithm. This algorithm uses a deep first search. So have you gone through this depth first search? You were at semester 2, right? So you might not have gone through it. So it is a searching technology, searching technique. Uh, so it searches through going to the depth of a dataset. Okay. To find frequent item sets, it's faster than a priori and often used in large datasets for association rule mining. Fine, it is faster than a priori. Okay, so we'll understand this association rule in our practical session. Okay. So applications of unsupervised learning. Apart from this, can you mention one application for unsupervised learning? Let's suppose clustering. Can you give one example? Anyone? Try to give any simple example. Okay, fine. So it can be used in market segmentation. Okay. So businesses use unsupervised learning to categorize customers into distinct groups based on purchasing behavior, allowing for targeted marketing strategies. So in my example, this one. So here you can say that this is a market segmentation dataset, and we can use K-means clustering to get multiple clusters of customers, right? So this is one example. And there's anomaly detection. Unsupervised methods identify unusual patterns in data, right? It can detect unusual patterns, okay, such as fraud detection in financial transactions or identifying fault in manufacturing processes. Fine. These are some real world use cases, okay, of unsupervised learning. Actually, unsupervised learning is quite a big field. It can be used for like the generative AI or something. We can use this unsupervised learning techniques. Okay. So image comparison is there. Techniques like PCA helps reduce the size of image. Okay. While retaining essential features. I have already explained what is PCA. It does what? It reduces the dimensionality. So it reduces what? It drops the less important features, still retaining the essential features. Okay. Making storage and transmission more efficient. Okay. If the picture size decreases, then it is easy to be stored and also transmit, right? So these are some application of unsupervised learning. In the next slide, we have unsupervised learning's major challenges. So every technology has some set challenges. So understanding interpretability in models. So the results generated by unsupervised learning techniques often lack clarity. So sometimes it does some clustering or some uh, good work, but what happens? We cannot clearly say that where we can use this, right? Sometimes it goes like that, making it harder for data analysts to make decisions, okay, to extract actionable insights. Fine. Thereby complicating the overall decision-making process significantly. So this is one of the challenges of unsupervised learning. And next, we have scalability issue in machine learning. Certain algorithms face substantial challenges when dealing with large datasets, which can result in significantly longer computation time. Okay, and insufficient resource uses, and particularly in real-time applications. So in the real-time applications, the scalability issue is there. And next, we have lack of ground truth in data evaluation. In the absence of labeled training data, the evaluation of model performance becomes a formidable challenge, right? In the absence of labeled training data, that means unsupervised data set. So there is no labels. So it is quite difficult to take out any decisions. Fine. So next we have tools and libraries for unsupervised learning. There are multiple tools and libraries. These are scikit-learn and TensorFlow. These two are libraries, and this is one language, R language. Have you heard about R? It is similar to Python. Have you heard about earlier? Yes, no. Anyone?
No, sir.
Okay. Okay, we'll use the Python language. Don't worry. So scikit-learn, it is a popular Python library that provides simple and efficient tools for data mining and data analysis, including various unsupervised learning algorithms. So this library has all these supervised learning, unsupervised learning algorithms inbuilt, right? Yesterday, if you remember that, we call the algorithms, right? Like logistic regression algorithm, we have called that from uh, these libraries. Okay, and we have TensorFlow, an open source library used for machine learning and deep learning purpose. So this is mainly used for deep learning, and then it includes autoencoders and clustering algorithms. Fine. And R language, it is similar to Python language. It also has some libraries, and it is good for visualization in a supervised or unsupervised learning. Fine. Next, we have future of unsupervised learning. So can you tell me any future aspect where we can use unsupervised learning? Do you have any idea? Okay, so we can do what? Sometimes it is difficult to use unsupervised learning. So we can do what? We can combine unsupervised and supervised learning together, and it can enhance the model performance. Okay, we have learned supervised learning yesterday, and this is unsupervised learning. And you can combine the technologies, and these two can enhance the performance. Okay. An advantage advancements in algorithms. Ongoing research is expected to improve existing algorithms, making them more efficient and capable of handling larger datasets. Okay, this is one future aspect of unsupervised learning, that algorithms should be, we can improve the algorithms. Okay. and real-time applications. As technology advances, unsupervised learning techniques will be increasingly implemented in real-time applications such as fraud detection and personalized recommendation systems. Okay. So in conclusion, unsupervised learning is a powerful tool in data analysis, proving valuable insights without the need of labeled data. So understanding the different type of techniques crucial for effectively utilizing unsupervised learning in practical scenarios. Okay, and exploring potential as technology enclaves the potential and capability of unsupervised learning are likely to expand, opening new uh, avenues for innovation and discovery. Fine. These technologies are rapidly booming, if you know. Okay. So do you have any question from these earlier slides? Anyone? Or if you have any question from yesterday's session? Okay, so why this is a non-unlabeled data? Why do you think this is an unlabeled data? And I've shown you yesterday what are the labeled data sets. Can you tell me why this is an unlabeled data set? Because the every coulombs here are independent. Okay, there is none there are no output coulomb is there. Okay, no dependent coulomb is there. All are the independent coulombs. Fine. You got the basic difference between labeled and unlabeled.
Yes, sir.
Okay. So you don't have any question? There are 43 participants. If you don't have question, then we will resume the session after 30 minutes. We'll resume the practical session. Fine. Okay. Join at 11:35. Fine.
Okay, sir.
Okay. Thank you. Okay, let's wait for another 2 minutes. Let's start. Am I audible?
Yes, sir.
Okay. I've shared on the dataset. Please download that. Have you received the dataset?
Yes, sir.
Please download that. Upload it in the Google Drive. Everyone, please go to WhatsApp. I've shared one dataset. Please download it and upload it in a Google Drive. After that, you have to mount the drive in a Google Colab. Okay. And I'm requesting you to follow my steps. Are you following me?
Yes, sir.
Okay. Have you uploaded it in the Google Drive?
Yes.
Yes, sir.
Okay. Are you able to mount it with Google Colab?
Yes. Done, sir.
Okay. Yeah. This is the process. For others, this is the process. Okay. So let's start. First, we'll do, let's see the dataset first. Okay. So here is the dataset. The same dataset that I have explained it in the theory session. Right. There are 5 columns, and we need only 2 of them. This annual income and spending score. Okay, we'll do clustering for these 2 columns. Fine. So here first we will call the libraries. Okay. First of all, we need pandas. Next, we need I've told about this sklearn, right? Mm, Let's try to do k-means. What is this k in k-means? Do you remember? Anyone? Do you remember what is k in k-means?
Unsupervised machine learning.
No, yeah, this is unsupervised machine learning, but K means number of clusters. Okay,
Yeah.
good. So here we are supposing that there are two clusters. Okay, there are two clusters, and we are doing taking the data points as randomly. So here we have to upload, keep the path of this data set. Okay. What's the name? What was the name of the data set?
mallcustomer.csv.
Okay, thank you. Mall customer. Yeah, this one. So in this way, you can copy the path. Okay. Locate the file, copy the path, and paste it here. Fine. Paste it here. Thus, the dataset will be loaded there. And okay. First, we have to do. So how we can get this number of clusters? I have put it randomly, right? But it is not that easy to calculate the number of clusters. So there is another method to get the K value. That means number of clusters in K means. The name of this algorithm is elbow method. Okay. So let's do the import for elbow method. Okay. We will plot the graph, and you can clear your concept there. Right? We need matplotlib. These are libraries, okay? Fine. So let's print the head of this data. So this is the data set. There, it is showing first five rows. Okay. So the data set is loaded in DF. That means data frame. So this data frame contains the dataset. Okay. Fine. After that, we'll split the data. Okay. It's equal to TF. So we'll consider the two columns only, that are annual income and spending score. Okay.
Is that a dollar sign after K?
Yes, that is like here in this name, it has a name as K dollar. That means $1,000. Okay, this is name, so we have to keep it the same. Fine.
Sir, can you please zoom in?
Okay.
Thank you.
Yeah. Is it visible now?
Yes.
Yes, sir.
Okay. So we are considering only these two columns in X. Okay. This much clear till here? Okay, let me
Yes.
add a comment line here. This is what? Relevant features. Okay. That relevant features for payments. Okay. After this, we will load. After this, we will do elbow method. I will explain what is the elbow method. Okay, don't worry. So we are taking a variable. That is what this sign means. It is an array. Okay. So here k range means it is a variable which hold a range from 1 to 11. Fine. So the elbow method does what? It will take k from 1 to 11 in a loop where it will apply k means for k equal to 1, k equal to 2, k equal to 3, like that till 11, k equal to 11, and finds where the algorithm does is performs best. Okay, we'll see. Let's create the for loop. Okay. So let's see. Okay. So it will do what? Comments is another variable where this k means it is calling the library. Fine. Okay. N clusters means number of clusters, that is k. K comes from here. Okay. From k range. First it will be 1, then 2, then 3 from this for loop. You are familiar with this for loop, right? This kind of loops.
Yes, sir.
Okay. Concept is same. You might have learned C language. The concept is same. Have you learned Python in your course, in your semester?
No, sir.
No. Yeah. So which language are you familiar with?
C.
C. Okay. There you have covered this loop and all.
Yes, sir.
Okay. So similar concept is here. It will move from 1 to 11. Okay. K in range. K range means this 1 to 11. So it will take first K1. Okay. Here. And clusters will take 1. Then after the loop, it will again take 2, then take 3. This type. It will auto increment. Okay. So this, after that, let's plot the graph. Are you getting this kind of sessions?
Yes.
No, sir.
No. Okay. Take your time. I will wait. Okay. So X level, Y level. Let us add a title. This is for visualization part. Okay. PLT means it will plot. It will use matplot.lib. That means matplot library. Okay. And it will plot the graph. Let's add grid here. Grid. I've done till here.
Yes, sir.
Okay. Let's run this to plot in a graph. Yes. So you can calculate there are 11 points like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 points from 1 to 11. Okay. That is because it takes from 2. Okay. So in the elbow method, it takes the optimal value. Okay. Inertia means it is a squared error, mean squared error, which is a mathematical term you have to calculate if you want. But this is a inertia means this is mean square error, where if the number of cluster is 1, that means what? There is only one cluster. The entire data points will covered under one cluster. Okay. So if the k is 1, if the k 1, then is it of any use? There is no use of a single cluster. Okay. There is no meaning. So it has highest level of errors. And next, if we use two clusters, okay, if we use two clusters, then also then the error rate will be reduced, but it has a large amount of errors. Okay, so we have to find the elbow point where this graph gets flattened. Okay, so here this is the elbow point. Fine. This comes in position 5. Okay, this comes in position 5, and this is the elbow point where the optimal number of clusters is there. Okay, so this is the use of elbow method. So are you done till here?
Yes, sir.
Okay, yeah, there are 10 points because this starts from 1 to 10. Okay, if we use like range from 0 to 10, then it will be also of 10 points. Fine. Okay, next we will do the k-means clustering part. Actually, it does what? It calls k-means clustering for 10 times for 10 different 10 number of 1 to 10 number of clusters. Okay, and it gets the best output for uh, here for fifth cluster. It gets the best output. Okay, here is the elbow point. Fine, here the graph gets bent. Okay, fine. Next, let's start the next part, that is k-means. Let's check cluster levels. Now visualization part. Six. Okay. I think we need this. Okay. So till here, let's check. Okay. So here are the clusters that have been made by the k-means clustering. You can see there are 5 clusters, 1, 2, 3, 4, 5. And these are very accurately separated from each other, right? So if we use 2 clusters, let's suppose, check what will happen. So here are the 2 clusters, right? We can clearly see, yes, that these data points and these data points are little bit different, right? And these data points are equal to these data points, then these green data points, right? So the clustering is not done very efficiently for 2 clusters. Okay, there are cluster 1 and cluster 2 only. There are 2 clusters. If we try to do for 3 clusters, see what will happen. So there are 3 clusters. Now the cluster points are, the clusters are separated. These 2 clusters are separated. And the distance between these 2 are quite high, but there falls in the same cluster. Okay. So this is also not efficient clustering. As you can see this, right? You can visually see this, that these 2 are having much stiffer data points, but still they are counted in a single cluster. Fine. So we use this ELBO method to get the effective number of k. Okay. To find the effective number of k. So here in the plotting part, this is data. Okay, data means DF has all the data set. Okay, so data means the data set is loaded here, and X means the annual income. Fine. X means the annual income here. X means the x-axis. X-axis has the annual income. Y-axis has the spending score. So according to the X, Y, the data points are placed. Okay. Are you able to understand how these points are placed here?
Yes, sir.
Okay. And others, do you understand? It is simple, like there are 2, we considered only these 2 columns, right? So 15 comma 39, 15 is X, 39 is Y, 15 comma 39. Okay, so let's see where is 15 comma 39. Maybe here, this one is 15 comma 39 point. Okay, am I right, Vishal? Am I right? This must be the 15 comma 39 point, right?
Yes, sir.
Yeah. So in this manner, all the data points are placed. After that, the distance is calculated, as I have shown in the presentation, that Euclidean distance. Okay, and the number of clusters is defined by what? This elbow method. Okay, and then we have due, that means or hue, that means the color. Okay, color of the clusters. Fine. And this palette, let me see what is this palette. So okay, it is used for predefined colors. Okay, and S100 means the size of these small dots. Fine. Okay, so let's increase the number of clusters. Let's increase it for 7. Let's see what will be happen. Yeah, you can see what it does. It separated these two clusters. It separated these two as different clusters. Okay, some data points from this cluster goes to this, and some data points, these three are belongs to this cluster, goes for this cluster. Fine. So the optimal value of clusters would be what? 5 for this data set only. Okay, fine. The centroid are placed somewhat here, 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 and here. Okay. Till here, are you able to understand? Yes, sir. Is it clear? Do you have any doubt or any confusion? We can add some more things here. Let's plot. The solution. Fine. Let's plot the title also. It will. Okay. Scatter against stop. It is saying that cluster center is not a object from K-means. So check it. Maybe it is printed twice. That is why it is showing. Yeah. Are you getting this error? Let's try to resolve this. Yeah. Okay. There are two columns, right? This can make the error. Okay, let's see now. Cluster center.
Sir, I'm not getting any error.
You are not getting any error?
Yes.
Okay. I don't know what is happening right now. Scatter. Have you modified something anywhere?
No, sir.
No. Use the same code. Let me run all them.
Sir, I have not written that s equals to 300. Then it's
Okay.
running.
Let's try for s equal to 100. No, it is not the thing. It is saying a cluster center is not an object from this one. And can you share your screen?
Okay, sir.
Yeah. Yeah, these are the centers. And these red dots are the centroids. Okay.
Mm.
And C equal to red. K-means cluster center. Okay. Okay, fine. Let me share now. Okay, so seeing this centroid points, right? Fine. So everyone understood this? Others?
Yes, sir. I got the output.
Okay. Vishal got the output. Anyone else? What about others? Are you following or not? There are 39 participants. It is not. Okay. There might be some spelling mistakes. That is why it was not running. Anyone other facing the same issue? Anyone else? Try to check for spellings. There might be some spelling mistake. Okay, so these are the centroids, right? These are dots are the centroids. There is a level. Okay, I guess you have understand the k-means. Next we will see another. Let's code it here. Okay. I've told you about a priori algorithm, right? Do you remember a priori algorithm? The association rule based algorithm. What I have told you that this algorithm do what? It finds the pattern, right? The relationship. It finds the relationship. Okay. So let's start. Okay. So priori. First import panda. So do you know why we are importing pandas? Pandas is a library which deals with what? Data frames. Okay, fine. It is used for reading the data set Okay, loading the dataset. Okay. This is a priori and association rules. Okay. From ML extend and frequent patterns, we are importing a priori and association rules. Fine. These all are libraries. Okay. And this is giving us the suggestions from this comment line. Okay, we are writing this comment line so that it can understand what we are trying to do, and it suggests us from that. Fine. So let's take a sample dataset. We are not going to give any long dataset. We are just taking one sample. Okay, we'll create our dataset. A very simple dataset. Fine. It has let's suppose this is a store where customers buys different things. Okay, these are transactions. Okay, each one of the element. This is a 2D array. Do you know about 2D array? Two-dimensional arrays?
Yes, sir.
Okay, great. So this is a 2D array. So each array in the that means in the inner arrays are one transactions. Okay. So there are milk, bread, let's suppose egg. They're purchasing these 3 items together. Okay. This is one transaction. Then we have another transaction of, okay, it is suggesting everything. Bread, egg, milk, bread, egg. Okay. Fine, we are taking this. Okay, this is the dataset. Fine, sample dataset. Now, let's run this first. Okay. Now you have to do one thing. We have to calculate how many number of items present there. Fine. First, we have to calculate how many number of items present there. How many number of items, unique items present there? One is milk, bread, egg, 3. 3 number of items present there, right? So in the first transaction, how many number of milk, the frequency of milk present there? In the first, there is 1. In the third, there is 1. And in the fourth, there is 1. That means milk present 4 times. Milk present 3 times in the entire data set, right? So we have to calculate this through one-hot encoding. So do you know about one-hot encoding? Might not know about this. One-hot encoding. So one-hot encoding means if the instance has milk, then it will give 1, and the other instances will get 0. If the instance don't have milk, then it will get 0. This is called one-hot encoding in simple terms. Okay. So let's do it. It's a variable t that for section encoders. Okay, transaction encoder. So it is an encoding technique. Okay, one hot is an encoding technique. It encodes the entire data set as if the data set is trying to get the number of milk, then it will convert the data set to milk 1, bread 0, egg 0. Okay, like that. Fine. For each one element, it will do that. Fine. It will transform the data set and make it one hot encoding. Okay. So finally, the data frame have what? Data frame have T array, that means transaction encoder array, and coulombs. Okay. So I have not defined it. I have imported, right? No. Okay. I have to import transaction encoders. Okay. Yeah. This is the transaction encoder. Fine. Yeah, it's running now. After applying 100 encoding, so this is the example. Okay, for bread in the first transaction, it is there, so it is true or false, or 1 or 0. Okay. Does the one hot encoding works? Okay, bread is there in the first transaction, so it is become true. Egg is there, true, and milk is there, so it is become true. Fine. And in the second transaction here, milk is not here, right? So milk becomes false. Okay. In the third transaction, there is no bread, right? So the person might not get bread, so it becomes false. So do you understand the one hot encoding part from here? It is
Yes, sir.
simple. It is for calculating the numbers. Fine, and make it simple. Okay. Okay. Now we will apply a priori. Algorithm. See, when I declare the comment line, it automatically suggests some lines. Okay, some code, right? So you have to click tab to get them. Okay. And you have to check if they're fine for this code. The minimum support is 0.5. So there one term is there, this minimum support. Okay, minimum support means the number of items present. It is basically getting the frequency. Okay, so there is if the item is less frequent and it is occurred less than 50%, then it will not be considered. Okay, this minimum support means that fine. Suppose there is a very big supermarket. There might be thousands of customers visited every day. So some items are very infrequent. Okay, very rare to be used by the customers. So we can ignore them. Fine. So we have to find the association rule here. Okay, association rule means we have to find a pattern where if a person grabs something, if you visited a supermarket and you grab some food item or any item, then the next item, what could be the next item, right? So this is this thing we have to extract, fine. So we are using this minimum support because some people do what they are very different from others. They can take bread with like some other fruit or some other item like household items. Okay, so that kind of purchases we ignore them. Fine. So this is minimum support. Okay, we have to give a priori algorithm the data frame, the minimum support, and coulombs. Okay, use coulombs. Are you getting? Am I able
Yes, sir.
to explain it properly?
Yes,
What do
sir.
you think? Okay, thank you. Let's run this. So the supports are here. It is taking more than 50%. Okay. Egg and milk, egg and bread, milk, egg, bread. These are common items that are present in this sample data set. Okay. So we are going to find the association rule among these items. Fine. Great. Next we have we want to generate the association rule. The association rule. Fine. So let's take rules as a variable. And here we have association rule, metric confidence, and minimum threshold 0.5. Okay. Frequent item sets. Fine. Let's check. I don't think minimum threshold is correct for this data set. It is. Okay, here this confidence meaning that the items of the association rule must over 75%. Okay. There are lots of other matrices, but I don't think we need them. Metric we use, let's use lift only. Fine. And minimum threshold, we decrease it to, okay, let's check. Let's display the result first. It was print frequent frequent items. Okay. Frequent item set. So here is the association rule. Confidence and okay. These are the frequent items, right? Bread, egg, milk. These are the most frequent items. Egg and bread together is the is one association rule. Okay, if one person picks egg first, then there is most probability, 60% probabilities are there that he might pick bread together with egg. Okay, and there is a similar possibilities that if he picks egg, then next item he might get will be milk. Okay, these are the association rules. Fine, and frequent items. Okay. Fine. We understand to get this.
Yes, sir.
Okay.
Yes, sir.
This is a small example. There might be thousands of items in a single transaction, so it is useful there. Okay, to predict or to keep keep items in a similar in a near position, or you are getting suggestions in online purchasing, right? In Flipkart or Amazon, right? So there, if you add one item in the cart, there some suggestions popped up, and it will suggest you to take some items relevant to your previous item, right? Does things are done from by this can be done by this a priori algorithm, or there are some other algorithms called frequent pattern mining. Okay, to get the idea.
Yes, sir.
Okay, have you done this program, coded it?
Yes, sir.
Okay. Any question? Anyone? No? Okay, I will stop sharing now.